all my PowerPoints so they all look the same. So they're all organized in a similar fashion, okay? So you can kind of follow them really easy. All right? So, chapter 3, guys, describing sound waves is what we're talking about today. Can somebody tell me can you tell me what are the acoustic variables? Can somebody help Win out? Not Samin. Myra, help Samin out. Those are our acoustic variables. Lauren, what do acoustic variables do?
It's not describe. It's the other way.
Come on, Lauren.
Identify.
Come on, Lauren.
Define the way.
It's only one Lauren, guys. When I call somebody, please let that person answer. That is so disrespectful. We talked about this already. Thank you, Lauren. Identifying sound waves is what acoustic variables do. Okay? What do acoustic parameters do? Describe sound waves. How many of them are there, Adelie? 7 acoustic parameters. Okay? Well, and when we're talking about acoustic parameters, we're really talking just about sound waves in general, because the next chapter, chapter 4, we're going to break that down. We're going to talk about the acoustic parameters for pulse waves. Okay? So we're talking about we're just talking about sound waves in general. All right? So this chapter right here, guys, again, like I said, we're going to discuss and describe the 7 parameters of sound waves. And you see they're arranged in this nice little box. For those who made it to the end of the chapter, you know why they're arranged in this manner. When we get there, I'll explain that and why they're grouped off like this, because hopefully it helps you guys remember and kind of understand their relationship with one another. Okay? So we have period and frequency. As you already know, what is period and frequency for an answer? How's their relationship? There's only one for an answer. What's your name? Okay. Amplitude, power, and intensity are our other 3. These are also known as our bigness parameters. Okay. And we have wavelength, and then we have speed or propagation speed. Okay. So those are 7 acoustic parameters. But we're gonna when we're talking about the parameters, of course, they describe the features of a sound wave, right there, guys. On the second page of the paper I gave you, it's an area for additional notes. If you look on the second page right there, if you have you want to take some additional notes, I did give you guys a little section where you can write down some more notes if you need to. Okay. I try to, I'm trying to do my best to help you guys out. All right. So when we talk about the value of all 7 parameters, these are all required to completely describe a sound wave. So as you can see on the paper, it's important to know the units, and I like how the book really breaks all of them down just like this. So it's really important to know the units of each parameter, the typical values or the range of each parameter dealing with diagnostic ultrasound, the synonymous terms or names associated with each parameter, and also whether the parameter is determined by the sound source or the medium itself. Okay? So this will help us understand how these parameters relate to the physical principles of ultrasound physics. So we're talking about the sound source, guys. We're talking about the ultrasound system and the transducer that's created by the manufacturer. Okay? So of course, when something's controlled by the sound source, that means that it's not adjustable. That means we as a technologist can't control it. When we're talking about something being adjustable, we're saying that, it's a button on the machine that can control this certain parameter. Okay? So when we're talking about the source, if it's controlled by the source, that's already implemented by the manufacturer, but that includes the ultrasound system and the transducer. Some of these parameters quantity can be adjusted by the sonographer, whereas others cannot be changed. All right? And when we talk about the medium, of course, that's the tissue through which sound is traveling. Okay? We're good on that, guys? Sweet. I'm sorry?
Can you repeat them?
About the sound source?
The medium?
The medium is just the tissue through which sound is traveling. Remember, it has to travel through something. I mean, I don't even want to just because this chapter is just focused on diagnostic ultrasound. That's why it says the tissue. So when we talk about a medium, it's any device or anything that which sound travels through. As you'll learn, and we'll talk about different things that sound travels through later, and the speed at which it travels, fastest to slowest. Yes, ma'am.
We're talking about ultrasonic sound or audible sound.
Audible,
Which is
you know,
general.
we're talking about whenever we're talking about it, we're always talking about diagnostic ultrasound. Diagnostic ultrasound. We don't really comment on audible sound often. Okay? We're gonna be talking about diagnostic ultrasound. Okay? That's why it says the medium through which sound is traveling, when really the medium is anything through which sound travels through. Okay? I just want to clear that up. Right? So you have if you look on the top of your page right here, guys, you'll see it has the definition, the units, typical values determined by, and whether or not it is adjustable by the technologist or not. Okay? There you go, right there. So I gave you this because these are all the most important things concerning this chapter right here. You have to know all of these things, including, you know, and it's going to be tough to know the typical values, knowing those typical values. But also, like I said, knowing those units is going to help you remember those typical values. Okay? So, when we're talking about the period, we're talking about period. Mind you, we're just talking about a single wave, right? We're talking about a single wave. We're talking about the period. That's the time it takes to vibrate a single cycle, or the time from the start of one cycle to the start of the next cycle. That's just the time it takes to complete one single cycle, guys. So one single cycle, however much time that took to make that, that's whatever this is right here in time, that's gonna be my period. However long it takes to complete one single cycle. Okay? A single cycle. That's what the period is. That's the definition of period right there. Okay? Period is measured in units of microseconds. Okay? And that's all, and it's measured in microseconds because that's how fast, you know, these sound waves are actually traveling. All right? It can be also when we're talking about diagnostic ultrasound, it's measured in microseconds, but it can also be measured in any unit of time, seconds, hours, or days. But in diagnostic ultrasound, it's going to be measured in microseconds. Okay? Its typical values range from 0.06 to 0.5 microseconds. Okay? And these are it in scientific notation or engineering notation. Okay? You can also write it in the long form in that way. But for the purpose of this class, we're going to use our complementary units, and we're going to say 0.06 to 0.5 microseconds. Right.
This values is like the difference between
This is all diagnostic ultrasound. This is all the ranges
this
of diagnostic
what we
ultrasound.
use.
Right. Absolutely. Absolutely. So all of these would be concerning ultrasound. But the period, no matter what, whether a wave is ultrasonic or not, the period is always the time it takes to complete one single cycle.
Yeah.
Okay. All right. So the period, guys, is determined by the sound source. The manufacturer already establishes how long it's going to take to complete one cycle when they're building these the sound system and when they're building these transducers. Okay. So therefore, it is not going to be adjustable. We can't change the period of an ultrasound system or a transducer. We can't change that. It's already built in by the manufacturer. So however long, again, guys, remember we're talking about diagnostic ultrasound. You can't see these waves, so there's nothing I can show you to be like, hey, look at that. There goes a period right there. You know what I mean? You have to just imagine these things. You have to know that this is what's happening. You know? All right. So there's nothing I can show you to be like, oh yeah, that's the period right there. But these are the characteristics of a period. Okay. So this is a period right here. So you how to count. So the beginning of one cycle to the beginning of the next cycle. So if this is the start of this, I go up down to this right here. That's one cycle right there. That's one cycle right there. Up down again. That's another cycle. Up down again. That's another cycle. How many cycles are in here? Three. So let's say this is 1 second right here. How long does it take to complete one cycle?
It's a beat per second.
0.33 seconds, right? 0.33 seconds, right? Because I'm going to divide 1 second by 3, because it's 3 cycles. It's going to for one the period of this one cycle will be 0.33. You got me? So I just don't want to take the
1/3, right?
1/3, absolutely. A third of a second. Okay, it's gonna take a third of a second because there's 3 cycles in this in this wave. But I'm telling you, this is the end right here where this ends. That is 1 second. And if I ask you, what is the period of this? What is the period of these waves? You would say a third of a second or 0.33 seconds. 0.33 times 3 will give you 1, or 99.999 forever. All right, we're good at that end. We're good. Okay. You had that. I don't know.
So is that 3 period right there?
Remember, we're talking about time. We're talking about period. This is 3 cycles.
Oh,
These are 3 cycles. Period is time. That's why. Remember, that's why I have time bolded right there. Period is the time it takes to complete 1 cycle.
oh, okay.
The time it takes to complete 1 cycle. I just want you guys to understand, if you have to calculate the period, how to calculate that period. Okay. But of course, you would have to know, how long something is, right? You have to know the either the frequency or how long it is. Okay. So, period. So if I'm counting again, I don't just have to start right here. If I'm counting waves, it's just from one point of the wave to the point of the next consecutive wave. Okay, so I can still, if I wanted to start counting right here, 1, that's 2, that's 3, right? So actually it's 2. So if I start here, 1, 2, and then I have a half cycle right here, right? So I always start when I'm counting cycles, or when I'm counting single waves. I'm always going to start from the beginning. So I'll count 1, 2, 3.
Okay.
Okay. So the period, guys, the time it takes to complete 1 single cycle. Okay. Frequency. Any questions on period before we move on?
How do you determine the typical value?
That's determined by the manufacturer. Whatever the typical values, whatever they set as far as how long it's gonna take those cycles to be completed, that's already determined. Remember I said it's determined by the source. So whoever manufactured the machine, Philips, GE, Acuson, Sonosite, whoever those manufacturers are, they're determining the period. We can't change that. That's how the transducer comes. You just have to know the typical values. You have to know that range of time that it could be in. Okay. So guys, let's talk about frequency. Frequency is the number of particular events. I'm going to simplify it a little bit more. Frequency is the number of particular events that occur in a specific duration of time, or the number of cycles that occur in 1 second. In ultrasound, we're talking about the number of cycles that occur in 1 second. So, if we know that, what would be the frequency of this wave, of this pulse, if this was 1 second? If this was 1 second, we already know that would be 3 cycles per second. So my frequency would be 3 cycles per second. Okay, that's how frequent these waves are happening. Okay, that's how often these waves are happening. All right. So again, the number of particular events that occur in a specific duration of time. That's the generalized definition of what frequency is, because frequency just doesn't pertain to ultrasound. Just like the book gives an example of the frequency of presidential elections. It gives a bunch of examples in there, right? It says once every 4 years. It says 2.5
years
times per decade, and once 25 times per century. Okay, all of those are describing the same amount of the same thing. Okay, just similar to how we're changing our units. Okay, remember the total picture is not changing, just the manner of the presentation. All right, so the frequency, the number of particular events that occur in a specific duration of time, or in ultrasound, frequency for us is the number of cycles per second. All right, its units are going to be in per second, or it's going to be in hertz. All right, or it's going to be in hertz. So if we have 1 cycle per second will equal 1 hertz. So every cycle per second will be 1 hertz. So 1 cycle per second will equal 1 hertz. 1,000 cycles per second will be
1 megahertz.
1 million.
1 megahertz.
Kilohertz, 1,000.
Or 1,000.
1 million cycles per second would be 1 megahertz. So just think about our transducer. We have that C5 transducer. The C5, that means there are going to be 5 million cycles per second. That's why I'm telling you, ultrasound is happening so fast. Just think about when you're doing an ultrasound, how do you think it's able to look like it's recording live, right? It's the ultrasound sound waves are happening so rapidly that you can't even see that it takes time when you're moving, but it does. And you notice that when you start adding more and more programs onto your or applications onto your screen, okay? Because it'll slow down, okay? But that's just how fast these cycles are occurring in diagnostic ultrasound, because diagnostic ultrasound has a range between 2 megahertz to 15 megahertz, guys. Write that down. That is the range of diagnostic ultrasound. 2 megahertz to 15 megahertz. So I mean, how many I told you, how many is 2 megahertz?
2 megahertz, 2 million.
2 million hertz. 2 million hertz. Remember, big M stands for million. The small k stands for kilo or thousand. Okay. So you have to know your units. You have to know those prefixes that we previously learned in the last chapter.
The 2 megahertz, the 15 megahertz, that is the what?
In diagnostic ultrasound, that's our typical values. Those are typical values. So when you think about our transducers range, all our transducers we have, don't they range between 2 to 15 megahertz? All the ones that you guys use so far, because you use the C5, right? A 5 megahertz transducer. Use the 8 megahertz transducer in clinic, a 9 megahertz, a 12 megahertz. Remember, that's for the superficial structures. Okay? Remember, the higher the frequency, the more detail. The higher the frequency, the better the detail of an image.